So hi class, for this video, I want to talk about the application part of FTC2. So let me share the theorem with you. It's called the Net Change Theorem. Pretty much, we can use this theorem, we can use this principle to apply to any rate of change in natural or social sciences. So for example, let's talk about the rate of growth of a population. So let's call dn over dt is the rate of growth of a population. Then if you integrate, the integral is going to be the net change in population during the time period from, let's say, t1 to t2. I put over here, we're familiar with velocity and all of that. So for example, if an object moves along a straight line with position function s of t, we mentioned that before, then the velocity is v of t, which is the derivative of s, right? So the integral right there from t1 to t2, v of t dt, that integral is going to be the net change of position, or we can call it displacement. Now, if you want to calculate the distance the object travels during the time interval, we have to consider the intervals when the velocity is positive. When the velocity is positive, that means the particles moves to the right. When it's negative, when the velocity is negative, that means the particle moves to the left. Anyway, in both cases, the distance is computed by integrating v of t. And then you see that I put the absolute values right there. So we have the total distance travel, but we have to put the absolute values right there because we have to consider the negative and the positive. All right, so let's talk about the next example, example 6. A particle moves along a line so that its velocity at time is given by t squared minus t minus 6. So first, I want to find the displacement of the particle during the time period from 1 to 4. So you see right there, that's the equation. Based on the equation 2, I just pretty much copy it down. So s of 4 minus s of 1 is going to be the integral of v of t dt. And then I plug it in, t squared minus t minus 6 dt. Now, you take the antiderivative, we ended up with t cubed divided by 3 minus t squared divided by 2 minus 6t, and then we evaluate from 1 to 4. So after that, I plug it in, I ended up with negative 9 over 2, which is negative 4.5. So negative indicates that the particles move 4.5 meters toward the left because it's negative. All right, so for part B, we have to find the distance traveled during this time period. So we only care about from 1 to 4, right? So once again, I go back and then I take a look at equation 3 right there. That's the total distance traveled. So right there, that would be the total distance traveled. So that part is the total distance. Okay, so we know that v of t is t squared minus t minus 6. I have to factor it. So the whole point of factoring is we're gonna test to see where v of t is positive and where v of t is negative. Okay, so don't forget, I only consider from 1 to 4. So I know right here we have the negative 2 and then the positive 3. That's when things change. But we only consider at 1. So let's put it right here. Okay, so I'm going to test the interval. So let's pick 2. If I pick 2, I plug it in there. I'm going to get 2 minus 3, so it's a negative. 2 plus 2, so it's a positive. A negative times a positive is a negative. Okay, so from 1 to 3, we have negative. Let's say from 3 to 4. 3.5. I plug it in there, I'm going to get a positive. I plug it in the second factor, I'm going to get a positive. So positive, positive, so it's positive. So you see that V of t is negative on 1, 3. And V of t is positive on 3/4. Okay, so don't forget we only consider from 1 to 4. Okay, now we're ready to integrate. So from 1 to 4, we have to break it because 1 is negative and 1 is positive, dt. So from 1 to 4, I have a negative. I'm sorry, from 1 to 3, sorry, from 1 to 3, we have a negative V of t dt. And then from 3 to 4, we have a positive V of t dt. Okay, so I have to pretty much multiply the negative 1 to the function, the original function. So we ended up with negative t squared, positive t plus 6 dt, right? And then the other ones is exactly the same. So what I have is t squared minus t minus 6 dt. And then from here, we integrate. So we get a negative t cubed over 3 plus t squared over 2 plus 6t. And then we evaluate from 1 to 3. And then the next one is t cubed over 3 plus, I'm sorry, minus t squared over 2 minus 6t. And this time we integrate from 3 to 4. Okay, so if you plug it in everything, we're going to end up with 61 over 6, which is approximate to 10.17 meter. Okay, so the most important part of this problem is when you talk about the total distance, make sure you check for negative and positive of the function. Okay, so let me highlight it. I'm talking about this part and positive here. Okay, so everything changed here. There. All right. See you next time.